All right, so this is the back of yesterday's note page. We're picking up where we left off, still solving some trig equations with two different trig expressions. So definitely going to employ our trig identities to solve this equation. All right, so something that I would like to mention that I didn't mention yesterday when I was reminding you of things to remember or to think about. Over here on the left-hand side, I'm just going to write a little reminder. A statement like this, sine squared theta. When I go to check values for theta, I say theta is pi over 2. So I want to check sine squared pi over 2. Well, it's hard to do. So it's hard to interpret what this means. So I want you to remember that this means that I'm going to take the sine of theta, whatever the answer to that is, and I'm going to square it. It either means this is a true statement, or it means this. Sine squared theta is equal to the sine of theta times the sine of theta. It's really common for many people who are still adjusting to reading this notation, where the squared is kind of between the sine and the theta. Okay, this is not equal to. It's really common for people to think that that means sine of theta squared, where the angle is being squared. Theta is an angle. This is improper, and it's very common. So just want to point out that we do not want to do that. All right, now that I mentioned that, let's take a look at the equation. So it looks quadratic in nature because it's got a secant squared, t, all right? And so I'm looking at tangent and secant, and I'm wondering how they're related in the trig identities. I know that secant is not a reciprocal of tangent, so they're not reciprocal identities, but they do exist in a Pythagorean identity together, correct? Yes? The one that says this, secant squared, I'm going to do it in t since this one's in t, is equal to 1 plus tangent squared t. They exist together in that trig identity. So that means that I can replace secant squared t with 1 plus tangent squared t. And so yesterday I gave you advice when you're going to replace one trig expression with another. A lot of times it's good to isolate that value, that trig expression. So if you wanted to move the secant squared t to the other side of the equation, you could. You absolutely could. So we'll go ahead and do that, although it's an extra step. That is my advice. So if we go 2 tangent t equals secant squared t, that's interesting. So that's just me adding that to the other side. It's not required, but that's the advice that I gave you. Now, what would you want to do in order to solve this? We need them to be in the same trig expression, both in tangent or both in secant. What do you think would be quick? To replace tangent of t with the square root of secant squared t minus 1. Do you want to do that and introduce the square root into the equation? Or would you rather replace secant squared t with 1 plus tangent squared t? Replace what? Yeah, replace the secant, right? So anytime you can replace a secant squared or a sine squared versus to the first power, you should do that, because that helps you to avoid the square root situation. So here's what we have. 2 tangent t equals 1 plus tangent squared t. Yeah? So now they're speaking the same language. Remind yourself this. Anytime we use substitution with trig identity, when we're done, we have to check our solutions. You guys paying attention? All right. So now what's your plan? What do you think? To the right? Find the zeros? Okay. So we'll subtract this. and put it on the other side. Do you want to reorganize the other side as we go? Put it in descending order. So tangent squared t minus 2 tangent t plus 1. Reorganize and move the 2 tangent t to the center of the problem. And of course, at this point, you know that you have the option to replace tangent of t with x and use algebra, right? Do you guys want me to do that, or are you good leaving it in this form? Leave it? Okay. So 0 equals, so let's factor. So we're looking for the numbers that multiply to 1 and add to -2. -1 times -1? All right. So that means we're going to take, since our lead coefficient is 1, not tangent squared, let me back that up. Quantity of tangent t minus 1 times tangent t minus 1. True? So I think there's only 1 0 here. I don't have to write this twice. Tangent of t minus 1 equals 0, tangent of t minus 1 equals 0. That's silly. One solution, tangent of t equals 1. So that's step 1 of solving a trig equation, is to isolate the trig expression. Trig expression on the left, number on the right. We've done that. Now we need to figure out when is that true. So I'm going to scooch over here and draw a little picture of a unit circle. All right, so when is tangent equal to 1? That's when your sine and your cosine are the same value, because remember, tangent sine over cosine. Tangent is also positive up here in quadrant 1 and down here in quadrant 3. Also, tangent of t equals 1. 1 is the slope of the line for tangent. So that means from 0, 0, I'm going up 1, right 1, up 1, right 1. What line am I on? What angle am I on? The 45 degrees. That's right. Or the pi over 4. So here's pi over 4. And over here you're at 5 pi over 4. So what's a useful thing to have here is your values, your trig values, your sine and your cosine values. So here in this coordinate, if I'm at this coordinate and I'm on my unit circle, pretend I did a good job drawing one. If I had my iPad, that'd be beautiful. All right. The coordinates here are for cosine, square root of 2 over 2, and sine, square root of 2 over 2, right? And down here, at 5 pi over 4, it's negative square root of 2 over 2, and negative square root of 2 over 2. This is how we know tangent is 1, because tangent sine divided by cosine. Sine divided by cosine in that situation, positive 1. Sine divided by cosine in that situation, positive 1. So here's what we know. T equals pi over 4 and 5 pi over 4 for the tangent part of that equation. Now what we need to do is make sure that when we substitute it back in with secant, that it's still true. So let's just quickly, if you have your exact value sheet, you have this answer ready to go. But where on the unit circle would I find the secant of pi over 4? So look at what is secant in relation to one of these 2 points here. Which one is secant related to, cosine or sine? Cosine, right? And it's the reciprocal, right? So the secant of pi over 4 is the reciprocal 2 over the square root of 2. So there's our secant, right? And our tangent of pi over 4 is 1. And our cotangent of 5 pi over 4 is 1. What's our secant of 5 pi over 4 then? Over here. Negative 2 over square root of 2, right? It's just a reciprocal of your cosine value, right? So you don't have to rationalize it, but we could go ahead and just rationalize it. It's the square root of 2 and negative square root of 2, just to simplify the math a little bit. So I find my secant values on my unit circle. I'm going to pause for the phone. Now we're going to check our solutions. I feel like a dork. All right. So let's say t is equal to pi over 4. And we're going to plug that into our original equation and reinsert secant into the situation. So we're going to do 2 times tangent of pi over 4 minus Now look out. That says secant squared. So I'm going to choose to do the secant of pi over 4 squared. Remember that I told you about that. So be really careful. And this is supposed to equal 0, right? That's what our equation says, that it's supposed to equal 0. Okay, so what's the tangent of pi over 4? It's right here. 1. Yeah, we found it. And what's the secant of pi over 4? We found it. It's right here. Square root of 2 squared equals 0. So we have 2 minus 2 equals 0. So pi over 4, good solution, valid, satisfies the equation. So now let's check the other one. We're almost done. So we're going to check for 5 pi over 4. So we're going to plug it in. So 2 times tangent of 5 pi over 4 minus secant of 5 pi over 4 quantity squared equals 0. And if you've got this whole plug-in values figured out, you could probably skip the step where we actually institute the value for t and go straight from t equals pi over 4 to 2 times tangent 5 pi over 4, which is 1, minus negative square root of 2 quantity squared, plugging in the secant of 5 pi over 4. And then we'll simplify. So this answer is 2. What's this answer? 2. Yep, because negative times negative is positive. Square root of 2 times square root of 2 is 2. Also true. Therefore, both solutions are valid. Okay, so that one wasn't horribly bad. A lot of steps still, but not too bad. Now what I'd like to do is go back to this last problem on the front. Okay, I'm not going to lie. This one's a lot of work. Okay, so I'm looking at this equation, and I'm wondering what's making you go, I don't even want to do that problem. Anything? Let's square root. Right, I'd love to just get rid of it right now by squaring it. But if I don't do this, just watch. Think about this. If I want to get rid of this square root right now in this format, then I have, this is a binomial. I've just complicated the problem. So I would like to get rid of the square root. So I say we isolate this so that we can square both sides and get rid of the square root. And then we can go through with the process that we've already practiced. Do you agree? We should try that. So let's subtract sine of t to the other side of the equation. So we have 1 minus sine t equals the square root of 3 cosine t. Now, some of you might say, okay, well now let's divide by square root of 3. I don't think that that's a good idea because that'll create a fraction on the other side of the equation, correct? And an ugly fraction with a square root in the denominator. So I think at this point, it would be a smart idea to just square the left and square the right and get that square root of 3. The square root squared inverse so that the 3 is not under the square root. Okay, so over here, you're squaring a binomial. Remember the rule. Square the first term, 1. Keep the sign, minus. And then 2 of these, 2 times 1 times sine t. And then square the second term, plus sine squared t. And remember, I gave you the formula for that to put at the top of your note page yesterday. Also, of course, you could do this. You could just do 1 minus sine t times 1 minus sine t and go ahead and distribute that, FOIL that out, and get your answer. Of course, you can do that. On the right, let's square this quantity. So let's multiply it times itself. Square root of 3 times square root of 3 is 3. Cosine t times cosine t is cosine squared t. So better situation. Better situation. No square root. And what's really nice, now we have some cosines and sine squareds. They're easier to substitute. So what do you want to do? Pull out the sines and insert all cosines, or pull out the cosine and insert all sines? Okay, so we know that cosine squared t exists in the Pythagorean identity, right, with sine. So that would be 1 minus sine squared t, right? So I'm going to replace this with this. So we have 1 minus 2 sine t plus sine squared t on the left equals 3 times, now I'm replacing cosine with a binomial term, or set of terms here. So parentheses. So if I had my highlighter, I wish I had my iPad because I'd highlight those two things. I'm using substitution right there. Now, you may be going, okay, this is complicated and I just don't see what my next step is. If you're in that boat, if it was a boat, an analogy, you could replace all your sine t's with x's. So you might like this problem better if it looks like this. 1 minus 2x plus x squared equals 3 times 1 minus x squared. You might feel a lot more comfortable with that. If you do, what would you do in this situation to solve for x? Distribute. So we'll do the same thing here. So we get 1 minus 2 sine t plus sine squared t equals 3 minus 3 sine squared t. And then you just need to decide which direction do you want to go. Take everything on the left to the right, or take everything on the right to the left. Bring it to the left. So we'll subtract 3 and add 3 sine squared t. Make sure you're lining up your like terms because you are adding or subtracting here. So we'll do some vertical math. So this is negative 2 minus 2 sine t plus 4 sine squared t equals 0. Anybody feel the need to reorder that? Yes? So we'll start with sine squared. So 4 sine squared t minus 2 sine t minus 2 equals 0. Now at this point, I'm pretty much in this situation. 4x squared minus 2x minus 2. What would you do in this situation? Would you try to factor? Would you go to the quadratic formula? What would you do? Factor what? Factor out of 2? Oh, I like that you saw that. Okay, let's factor out of 2. So that would be 2 times 2 sine squared t minus sine t minus 1. Man, I am really popular right now. Microsoft Store, I don't want your stuff. Okay. So at this point, do you want to switch to quadratic formula or you want to continue trying to factor? Factor? Okay, so I'm looking for numbers that multiply to 2 times negative 1, negative 2, right? A times C term, and then add to negative 1. What are those terms? 1 and negative 2. Would that satisfy? 1 times negative 2 is negative 2. 1 minus 2 is negative 1. Right, so we're going to split this middle term up between them. You know you have to do that sometimes when your lead coefficient is something other than 1, unless you want to work a different way factoring that out. Boy, I'm running out of room. So this would be 2 times, I'm going to change this to a bracket, 2 sine squared t minus sine, no, plus sine t, minus 2 sine t minus 1 equals 0. So I just took this middle term, negative sine t, broke it up with 1 sine t and a negative 2 sine t. Now we cut it in half, factor the front, factor the back, right? So you have 2 times, well, they have common up here that I can factor out, sine t. So that would be 2 sine t plus 1. Okay, what do they have in common in the second half? We know that we want it to say 2 sine t plus 1. So what do I have to factor out of that? A negative 1. Yep. So final problem here. We have 2. And your common factor is right here. We just found it. 2 sine t plus 1. And then your leftover factors, sine t minus 1 equals 0. Ooh, this one's a beast. Lots of places to make mistakes. Can we find our zeros now? Can you see them? What's the 0 for this first quantity? Subtract 1, divide by 2. Negative half. How about here? Add 1. 1. So there's your zeros. And 2 can't equal 0, so that's not a 0. Oh my gosh. So step 1 for solving a trig equation is done. We have found sine of t. Now we have to find t. Almost done, almost done. So I'm going to my unit circle here. Let me scooch over. Remind me of my answers. 1, and it's sine, right? Sine's your y coordinate. So sine equals 1, so that would be up here at 0, 1, which is pi over 2. And also at negative half, which is down here. So that's here and here. So if my unit circle, pretend I'm doing a good job. I'm trying to do a good job. I go off my path. Oh, it's better than the last one. Yeah, it kind of does. All right. Oh man, I'm really having trouble with my pen here. Okay. Negative half on your y coordinate. What angle am I on when my sine is negative half? Am I in the pi over 6? The 30. I heard it. The 30. Those are the pi over 6s, right? So this is 7 pi over 6 and 11 pi over 6. So what are our cosines? Because I do have to know them when I'm checking my answers. What's the cosine of a 30-degree angle? Square root of 3 over 2, right? So this is negative square root of 3 over 2 because I'm on the left side of the x-axis, and over here positive square root of 3 over 2. Okay, so there we have it. Oh my gosh, we are almost finished with the hardest problem we've solved this semester. I don't know, maybe not. No? Oh, okay. So pi over 2, 7 pi over 6, and 11 pi over 6. If this is not the hardest problem we've done all semester, then I'm doing a good job. Because I feel like this one's hard. Or it's at least a lot. Okay, but we use substitution to solve this equation, right? Which means that we have to check all of these solutions when we plug it into the original equation to make sure they satisfy. So does it say 1 equals? Shh, guys, we're not done. It's 1 equals the square root of 3. And so cosine of pi over 2 plus the sine of pi over 2. So we're checking to make sure that the cosine of pi over 2, sine of pi over 2 satisfy the conditions for this equation. So we get 1 equals the square root of 3, and the cosine of pi over 2 is 0, plus the sine of pi over 2, which is 1. I believe this is true. Yes? Yes. So pi over 2 is a good solution. Let's check 7 pi over 6. I'll change colors here. So if t equals 7 pi over 6, we're doing 1 equals square root of 3 times, what's the cosine of pi over 6? Can I skip a step and just plug it in? What's the cosine of 7 pi over 6? Negative square root of 3 over 2. And man, I am out of room. Let me see if I can scooch it over a little more. There we go. What's the sine of 5 pi over 6? Negative half. So I'm skipping the step of actually plugging the angle in and just putting the value in. So that's 1 equals negative 3 over 2 plus negative 1 over 2. Right? Square root of 3 over 1 times the negative square root of 3 over 2 is negative 3 over 2. That's 1 equals negative 4 over 2. I don't think that's true. That's no good. So 7 pi over 6, no good. Extraneous. Last check. Hallelujah. Here we go. We're going to check for t equals 11 pi over 6. Let's squeeze in here. So 1 equals, what's the square root of 3? What's the cosine of 11 pi over 6? Square root of 3 over 2. Plus the sine of negative 11 pi over 6, negative half. So we get 1 equals square root of 3 over 1 times square root of 3 over 2 is 3 over 2. Plus negative 1 over 2. That's 1 equals 2 over 2. Truth? Check. That's a good solution. Therefore, our solutions are pi over 2 and 11 pi over 6. Okay? You can plug these equations into Desmos to check to see if your solutions are correct. I will give you a little advice. I think it's useful to do that because it's easy to make a mistake and get stuck. So here's what you could plug into Desmos. See this equation right here? I'm going to put a little tip over here. If I want to type this in Desmos, I would move the 1 to the other side. So I would do 3 cosine t plus sine t minus 1 equals y. And I would look for the zeros on the graph. Just tap the zeros on the graph, and you'll see if your answers are right. So it'd be good to have Desmos open so that you can look at it. It'll also give you a good indicator of when you have extraneous solutions. Of course, you can't use Desmos on the test. Be aware of that. Dang it. Okay. All right. So assignment is on Canvas, problems 4 through 8. I just wanted you to finish the one we started yesterday. Okay.